Hey guys, welcome back. I'm Shivacharan studying at Sri Venkateshwara College of Engineering, and this is a video assignment uh, relating to the basic concepts of probability theory in the field of engineering. So let's dive into the topic of probability. So, introduction of probability theory in engineering. Probability theory is a branch of mathematics that deals with the quantifying and uncertainty in events. Engineering probability theory is essential for analyzing and predicting the likelihood of various outcomes. By understanding probability, engineers can make informed decisions and design systems that account for uncertainties. And what is probability theory? Probability theory is a branch of mathematics concerned with analytics and random phenomena. Central objects of probability theory are random variables, stochastic processes, and events. The probability theory is a mathematical foundation for statistics. As a mathematical foundation for statistics, probability theory is essential to many human activities that involve like quantitative analysis of large sets of data. The probability basics. Probability is a measure of the likelihood of an event occurring, ranging from 0 to 1. 0 being the impossible and 1 being the certain value. The sample space represents all the possible outcomes of an experiment. For example, let's say tossing a coin and you have heads and tails. This sample space is going to be head and tail, and the sample space is going to contain two elements. Events are subsets of the sample space representing specific outcomes or combinations of outcomes. What is the probability of spinning blue? So here we have 6, 5, and 4, and we have total 8, where 3 out of 8 is the spinning of blue. The probability of spinning blue is 3 out of 8. Probability calculation. The probability of an event A, denoted as P of A, is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. The addition rule states that the probability of the union of two events A and B is given by P of A union B is equal to P of A plus P of B minus P of A intersection B. The complement rule states that the probability of the complement of an event A is given by P A complement is equal to 1 minus P of A. Conditional probability. Conditional probability measures the likelihood of an event occurring given that another event has already occurred. The formula for conditional probability is as given below. And conditional probability is crucial for analyzing complex engineering systems with multiple dependent events. Independence of events. Two events A and B are considered independent if the occurrence or non-occurrence of one event does not affect the probability of the other. The independent events given over here in the diagram or in the block, P of A intersection B is equal to P of A into P of B, or you can also represent it the other way around. The formula for independent events are P of A intersection B is equal to P of A. P of B, where P of A intersection B represents the probability of both events A and B occurring. Random variables. So here we are diving into the engineering concept of random variables, where it is a variable that takes on different values based on the outcome of random event. Discrete random variables. There are two types of random variables, as you can see in the block. It's discrete random variables and continuous random variables. So as given below, probability distribution of a discrete random variable and the probability distribution of continuous random variable, there is a bell curve for the continuous random variable. Discrete random variables can only take on a countable number of distinct values. Probability distribution. The probability distribution describes the likelihood of different outcomes for a random variable. The probability mass function, or the PMF, represents the probabilities for discrete random variables. The probability density function, PDF, represents the probabilities for continuous random variables. Expected value and variance. So the expected value is nothing but mean, wherein the formula for the mean is going to be sigma xi into p of xi. Of the random variable is the weighted average of all possible outcomes, representing the long-term average. The variance measures the spread or dispersion of the random variable around its expected value. Engineers use expected value to value and variance to analyze the performance and reliability of the systems. So as given below, this is the tabular column, and the mean formula is going to be given by mean is equal to sigma x into p of x, and that's how it's calculated. Probability distributions in engineering. The diagram describes about the normal distribution, and it has a bell curve. So the median value is going to be 0, and the total value is going to be 1. Engineers commonly use probability distributions such as normal distribution, exponential distribution, and Poisson distribution. The normal distribution is often used to model random variables in engineering due to its symmetry and widespread occurrence. Probability distributions help engineers estimate failure rates, reliability, and optimize system performance. Applications of probability theory in engineering. Probability theory is widely used in the risk analysis, reliability engineering, and decision-making process. Engineers use probability to assess the likelihood of failure, calculate safety margins, and determine optimal design parameters. Thank you, guys.